Hey, what's going on, guys? In this video we are going to see how to prove this one using well ordering property. Here this proposition says for all x belongs to the real number, if 0 is less than x and x is less than 1, then for all n belongs to the natural number, x power n is less than 1. Okay, we are going to see how to prove this one. First we are going to prove this one by contradiction. Here our claim is the one that comes after then, because if you have if then statement, the one that comes after then is our claim. So we have to negate this one to create a contradiction, and if we can prove the contradiction is wrong, it means it automatically says that the proposition is correct. Okay, now let's go ahead and do that. First we are going to let x belongs to the real number, because it's that's given here. Let x belongs to the real number. Suppose 0 is less than x and x is less than 1, and there exists an n belongs to the natural number. 1 is less than or equal to x power n. Let s is equal to n belongs to natural number. 1 is less than or equal to x power n. By our assumption, here you can see I negated this one, right? Here you can see in our original proposition, for all n belongs to the natural number, this is there exists and n belongs to the natural number, because if it's for all, the negation is there exist, and also if it's less than 1, we put greater than or equal to 1. Okay, that's negation. Now also we created a set that is equal to n belongs to the natural number, and 1 is less than or equal to x power n based on this. Okay, let's go ahead and continue by okay, by our assumption S is not an empty set. S is not an empty set. So if it's S is not an empty set, and if this is bounded below by 0, this applies the well ordering property. By well ordering property, S has the smallest element. Has a smallest element, and we are going to call this smallest element to be n. So let n be the smallest element of S. N be the smallest element of S. Since x power 1 is less than 1, because that's given in here, since x power 1 is less than 1, 1 is not in the set. 1 is not belongs to the set, and so n is not equal to 1. So n is not equal to 1. If n is not equal to 1, we can say n minus 1 is also not equal to 1. First we have to say n minus 1 is a natural number, but it's not equal to the set, actually not belongs to the set. So we have a natural number. If we can prove a natural number that contradicts this statement, then we can say this statement is wrong. It automatically means the original proposition is correct. Okay, n minus belongs to the natural number. Now n minus 1 not belongs to the set, because n is the smallest element. So n minus 1 means it's not in the set. N minus 1 is less than smallest, so it's not in the set, but it's a natural number. So if we can prove this one satisfies this condition, it means something outside of the set is satisfying this condition, that represent this is wrong. Okay, that's what we want, because this is our contradiction, and if we can prove this contradiction wrong, this means the statement is correct. Now n minus 1 will not belongs to the set, which implies that x power n minus 1 definitely less than 1. Okay, and then since 0 is less than x, that's a given right here. 0 is less than x. Since 0 is less than x, we have x times x power n minus 1 is less than x. This gives us 1 is less than 1 is less than or equal to x power n, less than x, less than 1. By transitivity, okay, and by transitivity 1 is less than 1, which is a contradiction. Let's continue here. I'm getting rid of this one, but if you make sure you note this one down, because this is what we are trying to prove wrong. Okay, let's get rid of this one and continue on top. One is less than 1, which is a contradiction. Therefore we can say, if 0 is less than x and less than 1, then for all n belongs to the natural number, x power n is less than 1. Okay, that's our final statement, and that is satisfying. That's our proposition. We proved that one is correct. Okay, thanks for watching, and if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. Don't forget to watch that too, and if you are don't forget to subscribe my channel too. Okay, thanks for watching. See you next time.